Hi. In this lesson we're going to take a look at Newton's third law. And oftentimes we see this law summarized as for every action there is an equal and opposite reaction. Sometimes this law is even referred to as the action-reaction law. So let's talk in physics terms about what this actually means. For every action there is an equal and opposite reaction. So in terms of force, if there is a net force applied from one body to another, then an opposing force of that same magnitude will react to that force. And let's take a look at an example. So if there's an astronaut in space, and the astronaut is currently at rest, and that astronaut were to take a mass, and let's say the mass of the object is 5 kilograms, and let's say the astronaut throws that particular object with an acceleration of 2 meters per second squared. So by applying that force and throwing that object, when the object is thrown in one direction, there will be an equal and opposite force on the astronaut in the other direction. So here, if you were to use Newton's second law, which if we look at our previous video, it's F net equals mass times acceleration. So here you would have ma is going to be 5 times 2, a force of 10 newtons. So here, if we have a 10 Newton force for the astronaut throwing the mass, then we're going to have a 10 Newton force in the opposite direction, pushing the astronaut backwards. And what we would actually see in space is that if the astronaut throws that object, then the astronaut, as a result of that reactionary force, would be moved back in the opposite direction. It's similar to the concept of recoil. For example, if you were firing a weapon, the recoil that you have is because of the force being applied in one direction, generating a reactionary force in the opposite direction. So let's talk here about why we don't always visually see that when we think of equal and opposite reactions. So in space, it's easier to picture things floating around. And in space, because there's a vacuum, you don't have any frictional forces that can prevent these reactionary forces from something that we can visually see. However, if we think of on Earth, if I were to take this marker right now and throw it in that direction, like that, we can see that I did not, in fact, move backwards or experience any recoil from that. So was Newton's third law actually at work in this situation? Well, the correct answer is yes. The law still applies, because if I threw that marker in that direction with a net force, let's say, for example, of 5 newtons, I experienced 5 newtons of force in the opposite direction, but the reason that I didn't move in response is because there's friction. When you're on Earth, for example, right now I'm standing on the ground, and so even that 5 Newton force, which is a pretty small force, wasn't enough to overcome the friction of my feet on the ground, and I was able to stay in place while throwing the object. So even though we don't always see every action generating an equal and opposite reaction, in physics terms, in terms of force being applied, this effect is always taking place. And if you have a 10 Newton force being applied in one direction, you have a 10 Newton force being applied in the opposite direction as a result. For more questions, please feel free to watch our other videos, or you can visit our website at www.sandersontestprep.com. The link is in the description below. Thanks for watching.